Have you ever wondered how a machine can learn? Not by magic, not by luck, by algorithms. But what does learning even mean for a machine? Let me put it simply. When we experience things, our mind recognizes patterns. A machine does the same, only its experience is data. Everything it sees, reads, or hears turns into numbers, and then it uses algorithms to analyze those numbers and find a pattern. For example, think about a face recognition model. It doesn't actually see your face. It just reads thousands of numbers representing pixel brightness, then looks for a specific pattern that says, "Aha, this is that person." Everything starts with data and ends with algorithms. But the bigger question is, which algorithm? Take linear regression, for instance. It's the one that tries to draw a straight line through the data and say, overall, this is the trend. It's a simple model, but it's the foundation of data analysis. Then comes the decision tree, a kind of question and answer tree. For example, is the salary high? Yes, approve the loan. No, reject it. It's a simple algorithm, but it's used everywhere from disease diagnosis to movie recommendation systems. Now let's move on to k-means. It's a model that doesn't know what things are, but it can still group them. It looks at the data and says, all right, these belong together, and those form another group. Without being given any labels beforehand, that's what we call unsupervised learning. And finally, we get to one of the most popular ones, neural networks. These are the artificial brains. Neuron after neuron, just like the human brain, only they work with numbers. Their power, they can understand sound, images, text, anything, as long as you feed them enough data. But well, the question everyone asks is, where do I start? That's where we step into the world of real projects. Before anything else, you need to know this. An ML project isn't just a model. It's a collection of files, data, tests, and configurations. In fact, it's a complete structure, not just a simple piece of code. To get started, you usually head to Kaggle. It's a platform where you can learn, find data, and even compete with others. There you'll find thousands of real datasets, from predicting house prices to recognizing facial emotions. All you have to do is pick one, download the data, and start experimenting with your algorithms. Later on, you'll come across Hugging Face. That's the world of pre-trained models. Models built and shared by companies and researchers so that others can use them too. For example, want to build a model that translates text? You don't have to start from scratch. Just go to Hugging Face, pick a ready-made translation model, and with only a few lines of code, you can fine-tune it or use it directly in your project. But remember, working with a pre-trained model is just the beginning. You need to know how to clean your data, how to test the model, and how to analyze its errors. Because in machine learning, data quality is more important than the algorithm. That means if your data is wrong or incomplete, no matter how powerful your model is, the output will be wrong. And this is exactly where most beginners fail. Want to know how a real ML project is built? First, you collect the data, then you inspect and clean it. Next, you choose and train your model. Finally, you test and save the results, usually in files like CSV, PKL, or PT. That's when you can finally say you have a real ML project. It looks simple on the surface, but every step is a world of its own. And this is just the beginning. The thing you need to remember is that machines only learn what you give them. If your data is low quality, your results will be too. But if you carefully choose the right data, even a simple algorithm can work wonders. So don't be afraid to start. Don't be afraid to make mistakes. Every great model began with a small file. Now it's time for you to build your own model. Are you ready? Because from here on, the machine is really going to learn.